I think there's a problem in our model for estimating damages from a flood. Okay, intern, this model's been built on extensive data and an industry standard over the last 50 years. Let me try to explain with an example. Suppose we have flooding of 4 feet. Using the existing model would predict an average structural damage of about 38% of a building's value. That sounds about right. 4 feet is a significant amount of flooding. The data shows the damage isn't uniform, but it's actually a bimodal distribution. Some buildings, about 22 of them, that suffer very little or no damage, and then another set of buildings, about 16 buildings, that are heavily damaged, over 90%. And then the rest kind of fit in between those two. Interesting. So you're suggesting that the classic model, which assumes all the damages are centrally distributed, might be oversimplifying things. Exactly. Looking at the data, we're overestimating the impact of shallow floods, but underestimating the impact of very high floods. That's a valuable insight that really could change our policy in flooding. And if I think about it, in other areas where we often work with money, we have bimodal and zero inflated distributions, so I shouldn't be too surprised.